Lessons learned from Near-Earth Asteroid 2024 YR4 and the International Coordination. That retired the 2032 Earth Impact Risk. NASA Planetary Defense Coordination Office. May 2025. Colonel Todd Borzik, U.S. Air Force One. NASA Skillbridge Fellow assigned to the Planetary Defense Coordination Office. Executive Summary, simplified and YouTube-ready English. In late 2024, Asteroid 2024 YR4 became the most concerning near-term impact threat detected since the famous discovery of Apophis back in 2004. Its discovery turned into a major international test of everything the planetary defense community has been building over the past few decades: new technologies, improved global coordination, and more advanced systems for tracking and evaluating potentially hazardous asteroids. What happened with 2024 YR4 showed how far planetary defense has come. Organizations across the world, NASA's Planetary Defense Coordination Office PDCO, the European Space Agency ESA, the UN Office for Outer Space Affairs UNOOSA, the International Asteroid Warning Network IAWN, the Space Mission Planning Advisory Group SMPAG, universities, observatories, private groups, and countless experts work together to detect the asteroid, refine its orbit, and ultimately move the risk of a future impact. Decades ago, an asteroid like this might have gone completely unnoticed, or astronomers might have lost track of it before determining its orbit. But with today's advanced, and importantly redundant, systems, the global community detected 2024 YR4 early, tracked it with increasing accuracy, and quickly evaluated its potential danger. The asteroid was discovered on December 27, 2024 by one of the newest survey systems on Earth, the NASA-funded Atlas telescope in Chile, operated by the University of Ha. Only 3 days later, on December 30th, it reached level 1 on the Torino scale, where several objects usually appear each year. But things got serious in late January 2025. By January 28th, 3 major orbit analysis groups, NASA's CNEOS, ESA's NEO Coordination Center, and NEODIS in Italy, confirmed that YR4 had a large enough size and a high enough impact probability IP to be raised to Torino scale level 3. This level is extremely rare. The last time the world saw a level 3 asteroid was 20 years earlier. Why level 3? Because calculations showed a 1% chance of the asteroid hitting Earth on December 22nd, 2032, combined with a size estimate of over 50 meters. That's more than twice the size of the 20-meter Chelyabinsk meteor that exploded over Russia in 2013, which injured more than 1,500 people and damaged over 7,000 buildings. Whenever an asteroid crosses the 1% threshold, NASA's PDCO is required to issue official notifications to U.S. agencies, while IOWD routes alerts internationally. Normally, the impact probability drops quickly once more data comes in. But in this case, the opposite happened, and the probability continued to rise for 52 days, peaking at 3.1% on February 18, 2025. To track the asteroid as it moved farther away and dimmed, increasingly powerful telescopes were needed. Smaller telescopes handled the first days after discovery, but later observations required the world's largest 8-meter class instruments, fit even the James Webb Space Telescope, which also helped refine YR4's physical characteristics, improving size estimates to about 67 meters. Between December 27th and late February, at least 63 observatories worldwide contributed more than 500 observations, ranging from backyard amateur telescopes to the most advanced facilities on Earth and in space. 24 observatories supplied the most important astrometric data, including recovery images, older photos, where the asteroid had been captured before anyone knew it existed, after nearly 7 weeks of global monitoring and analysis. The international planetary defense community was finally able to reduce the estimated impact probability to near zero. This confirmed that 2024 YR4 poses no threat to Earth for at least the next 100 years. All of this happened during major disruptions, holiday schedules, destructive wildfires that damaged the homes of 150 NASA JPL employees and temporarily shut down JPL servers, and a U.S. presidential administration transition that brought in new personnel unfamiliar with NASA's notification procedures. Despite these challenges, the planetary defense community adapted quickly and worked flawlessly. This document summarizes the event from start to finish and captures key lessons for future asteroid risk scenarios. These include improvements in notification processes, international coordination, astrometric data sharing, public messaging, and other areas critical to dealing with potentially hazardous asteroids, especially as more powerful survey systems come online and the detection rate of small but threatening objects increases. Introduction: simplified and YouTube-ready English. On March 3, 2025, NASA leaders Dr. Kelly Fast, Acting Planetary Defense Officer, and Lindley Johnson, Planetary Defense Officer Emeritus, launched a full review of everything NASA, U.S. agencies, and international partners did in response to Asteroid 2024 YR4. The goal of this review is simple: to document what happened, what the global planetary defense community learned, and how these lessons can improve our response to future asteroid threats, particularly those that rise above zero on the Terrestrial-impact hazard scale. Tracking how the world reacts to objects like 2024 YR4 is critical. The planetary defense community is preparing for a future where it must be ready to counter not only city-destroying objects, but potentially even region-scale impactors. Over the past 25 years, only 2 asteroids have ever reached Torino scale level 3 or higher. 99942 Apophis, a 335-meter asteroid, reached a peak impact probability of 2.7% in 2004. 2024 YR4, about 60 meters wide, reached a peak of 3.1% in 2025. The reason we were able to estimate the risks of these objects much more quickly than in the past is because global detection and tracking capabilities have improved dramatically. And the pace of discoveries is about to explode. In the coming decade, new telescopes and observatories will radically expand our ability to detect potentially hazardous asteroids. These include NASA's NEO surveyor launched no earlier than September 2027. The Vera C. Rubin Observatory, with its LSST camera online in 2025. ESA's FlyEye telescope completing in 2025. ESA's NEOMIR infrared mission planned for launch in the 2030 SS. NEO surveyor and the Rubin Observatory alone are expected to find 10 times more near-Earth objects than current systems can detect. This means that over the next decade, the planetary defense community may have to evaluate hundreds of thousands, or even millions of newly discovered asteroids. By reviewing what happened with 2024 YR4, from initial detection to final impact probability refinement, the community can prepare itself for this incoming flood of new data. The goal is to ensure rapid orbit determination, physical characterization, cataloging, timely public alerts, and mitigation planning whenever a real threat is identified. NASA assigned the task of building this review to Colonel Todd Borzych, a U.S. Air Force officer serving in NASA fellowship during spring 2025. In his role, Borzik conducted interviews with 36 experts worldwide, including astronomers specializing in astrometry and physical characterization. Survey teams, observers, mitigation planners, orbital analysts, and interagency coordinators. He and his colleagues also interviewed leadership at NASA, ESA, and multiple partner agencies. They reviewed a massive amount of documentation related to 2024 YR4, around 900 emails, internal briefings, scientific reports, web pages, public news coverage, and Slack discussions. The review additionally considers relevant policies, such as NASA Policy Directive 8740. 1. And the international notification agreements managed through the International Asteroid Warning Network IAW. Chronological narrative, simplified in YouTube-ready English. Discovery the 27th of December 2024 to the first full moon, the 12th of January 2025. Discovery of 2024 YR4. On December 27th, 2024, at 5:42 UTC, the new ATLS telescope station in Chile, operated by the University of Ha-AI, spotted several potential near-Earth asteroids during its routine survey for NASA. One of these detections, shining at magnitude 16.2, would later receive the designation 2024 YR4. The discovery happened just 2 days after the asteroid made its closest approach to Earth, passing at 2.2 lunar distances on Christmas Day, and as it moved from the daytime sky into darkness. At this point, the asteroid was already speeding away from Earth. For ATLAS and other sky surveys, detecting new NEOS is normal. Typically, astronomers don't know right away whether a newly spotted object is dangerous until follow-up observations confirm the orbit. At the time, ATLAS astronomer Dr. Larry Deno, who submitted the observations to the Minor Planet Center MPC, had no reason to think this asteroid was anything unusual. Only weeks later, in mid-January, the ATLAS team would learn that this object carried a much higher risk level than expected. Confirmation of the object. Following standard procedures established by NASA's Planetary Defense Coordination Office PDCO, the detection was automatically posted on the MPC's NEO confirmation page, NEOCP. This page lists new objects, requiring urgent follow-up so astronomers worldwide can confirm what the surveys have found. This triggered rapid follow-up observations by several telescopes, known as dedicated telescopes. Unlike survey telescopes that scan wide areas of the sky for discoveries, dedicated telescopes focus on specific coordinates to refine an asteroid's path with much greater accuracy. Rewritten conversational English version. Initial impact risk assessment. Right after the asteroid was discovered, 3 major impact monitoring systems, NASA/CNEOS's Sentry, ESA's Aegis, and Italy's Neodius, all picked up a tiny impact probability for the year 2032, roughly 0.05%. That might sound small, but on the Palermo scale it scored above 2, which is enough to trigger internal alerts for the teams and push them to double-check the data. Even though each system crunches astrometric data a bit differently, their initial results were very close, all within about 20% of each other. Still, because Aegis and Neodius calculated a slightly higher probability, they placed the object at Torino scale level 1, while CNews initially put it at level 0. Seeing an asteroid hit level 1 on the Torino scale isn't super common, but it's also not shocking. This happens a couple of times a year with today's global observation capabilities. Usually, once astronomers collect more follow-up observations, the estimated impact risk drops, and the asteroid goes back to level 0 pretty quickly. These automatic alerts are based on early estimates of impact probability and size, but they always need human review before anyone launches large observation campaigns. In Europe, Dr. Marco Micheli, one of ESA's astrometry experts, noticed the December 27th alert and determined there was enough time to track the asteroid and refine its orbit. Additional observations. Move the Torino scale to level 1. On December 29, 2024, Dr. David Farnacchia at CNEOS reviewed a new dataset released by the MPC, which included observations from December 28 and 29. The updated data confirmed that asteroid 2024 YR4 reached an impact probability high enough, given its size, to officially raise it to Torino scale level 1. CNEOS then updated its Sentry alert system, where level 1 is displayed with green highlighting. Dr. Farnocchia used a newer impact prediction method that he and Dr. Javier Roa developed with Dr. Steve Chesley. Published in 2021, this approach allows accurate impact probability calculations while being much more computationally efficient than Monte Carlo simulations. Early estimates suggested that 2024 YR4 was large enough to cause local to regional destruction if it ever hit Earth. CNEOS also found that the asteroid's orbit is almost exactly 4 years long, meaning it will pass near Earth again in 2028 and 2032. During the 2032 approach, it would get uncomfortably close, traveling 13 kilometers/superlative to Earth, or hitting at about 17 kilometers/says if an impact occurred. On the morning of December 31st, 2024, the Torino scale level was still holding at 1, so CNEOS notified NASA's Planetary Defense Coordination Office PDCO. NASA's internal dashboard, which pulls live data from Sentry through an API, also updated automatically to show the green level 1 alert. Dr. Farnacchia noted that 2024 YR4 would remain observable until at least April 2025, meaning astronomers would have plenty of time to gather additional data and refine the asteroid's orbit even further. For a while, astronomers weren't sure whether they'd be able to fully rule out the impact risk during the period when 2024 YR4 was still observable. As its appearance continued, larger and more powerful telescopes began scanning deeper into the sky. Between December 24th, 2024, and the full moon on January 12th, 2025, a total of 226 observations were submitted to the MPC, though the quality varied. Among these were several high-precision astrometric observations from major facilities. The 1.54-meter Danish telescope at La Silla in Chile, the University of Hawaii's 88-inch telescope on Mauna Kea, the 4.3-meter Lowell Discovery Telescope, and the 3.58-meter TNG on La Palma in the Canary Islands. Physical characterization challenges. Scientists who specialize in physical characterization, meaning they study an asteroid's composition, rotation, and thermal properties, generally don't monitor Sentry warnings closely. As a result, most of them didn't notice that 2024 YR4 had reached Torino scale level 1 early enough to take advantage of the brightest part of its appearance. By early January, more astronomers started paying attention, but these were mostly experts focused on astrometry, not physical characterization. And that's important because astrometric teams are usually the ones who track risk-listed objects and often rule out threats before physical observations become a priority. The problem is that opportunities for physical characterization are much more limited. The observations require the object to be bright, usually when it's close to Earth, and that window is much shorter than the one needed for simple astrometric tracking, which only requires the asteroid to be detectable as a point of light, radar observations. which can give extremely precise positional data, have an even tighter schedule. Radar can only be used when an asteroid is not just bright enough, but also physically close to Earth. And objects like 2024 YR4 usually fly past at very high speeds, meaning they're in radar range for only a brief period. For 2024 YR4, the only available radar system, Goldston, had just a narrow window, ending around December 29th, 2024, and even that was uncertain. Unfortunately, this was right before the asteroid's threat level was updated to Torino scale 1 on December 29th, 30, as CNEOS analyzed new data. If the Arecibo Observatory had still been operational, it would have had the power to observe the asteroid after December 30th. According to Dr. Lance Benner, Arecibo's radar imaging likely would have removed 2024 YR4 from the risk list early and dropped its Torino rating back to 0. NASA's Infrared Telescope Facility RTF in Hawaii had a slightly larger observation window until January 2nd, 2025. Using infrared spectroscopy and fast tracking, the IRTF can determine an asteroid's mineral makeup, rotation, and even estimate its size or albedo. But the RTF team didn't know about the asteroid's level 1 status in time to act. Currently, there's no automated system that alerts physical characterization teams about risk-rated asteroids, although NASA's PDCO and the International Asteroid Warning Network IAWO are discussing how such a system should work. In fact, after the 2024 YR4 experience, PDCO tested a new automated alert workflow in April 2025 when another asteroid, 2025 A22, briefly reached Torino Scale 1. The test system flagged the object on April 25, 2025, sending alerts to both IAW and PDCO, along with the usual manual notifications from CNOS. Polarimetry, a technique that can help determine an asteroid's albedo, might also have helped, but it's mostly done with small telescopes. These can only observe dim, fast-moving objects like 2024 YR4 for about the first 24 hours after discovery. Larger telescopes like the VLT can perform polarimetry too. But in this case, 2024 YR4 was at the wrong phase angle, meaning the geometry wasn't right to take these measurements. Even though the opportunities were limited, the redundancy of available telescopes and instruments allowed astronomers to gather enough physical characterization data on 2024 YR4 over the following lunations. In fact, some physical characterization was successfully done during the very first lunation. On January 3rd and 4, 2025, Czech astronomer Dr. Petr Pravec used the Danish telescope to measure the asteroid's light curve and determine its rotation period. His observations showed that 2024 YR4 was not tumbling. Later, Dr. Pravec and Dr. Divogio analyzed data from the VLT and confirmed that the asteroid was spinning rapidly, but only around its principal axis. Dr. Pravec and Dr. Maxime Divogila also estimated the asteroid's absolute magnitude at 23.8. As 2024 YR4 grew fainter and harder to study in detail, Dr. Pravec teamed up with Dr. Marco Micheli and others to continue using the Danish telescope for follow-up astrometric measurements. On January 7th, 2025, the Manos team used the relatively new Lowell Discovery Telescope LEDT, now about 13 years in operation, to collect spectrophotometry, basically the asteroid's color information. According to Manos principal investigator Dr. Nicholas Moskowitz, these observations provided an initial S-type taxonomic classification, which also gave researchers a first estimate of the asteroid's albedo. They also confirmed earlier reports that the asteroid's rotation period was roughly 20 minutes. On January 7th, 2025, Dr. Pravik emailed Dr. Julia de Leon to ask whether she could capture the visible spectrum of 2024 YR4 using the 10.4-meter Gran Telescopio Canarias GTC. She was able to do so on January 13th. The resulting spectra suggested the asteroid was likely an S-type or L-type, although a K-type, which has a lower albedo, was still possible during that observation window. California wildfires impact operations. On January 8th, 2025, strong winds and wildfires swept through California, forcing JPL to shut down its buildings and evacuate CNEO's personnel. It was the first time in decades that JPL servers had to be powered down. According to CNEO's director Dr. Ryan Park, the team managed to keep operations going thanks to Dr. David Farnakia, who continued working remotely from Idaho. He noted that Alan Chamberlain, working from New Mexico, played a key role in restoring systems, while John Giorgini, based in South Dakota, remained available to support the Horizon system, which observatories rely on to point their telescopes correctly. International coordination with NEOCC and NEODIS also became especially important during this disruption. The wildfires came close to Mount Wilson Observatory the following day, but fortunately did not cause physical damage to JPL. The lab remained closed until reopening in phases from January 21st to 27, 2025. Although JPL itself survived, 150 staff members lost their homes. Recovery searches during this and the next lunation. While new observations were coming in, astronomers around the world also began searching for recoveries, measurements of the asteroid and images taken before its official discovery. Good recoveries can greatly improve an asteroid's orbital calculations. According to Dr. Marco Micheli, the search efforts for 2024 YR4 were extensive. Teams examined older images from the Catalina Sky Survey, PAN-S, T-A-R-R-S, Gaia, N-E-O-W-I-L-E, Y-S-E, the U.S. Space Force's SST, TESS, and other exoplanet-mixoplanet missions, as well as datasets indexed through the Canadian Astronomy Data Center's SWIA service. They also checked DCAM images from August 2016 and B612's Atom platform. Dr. James Bauer, who took part in the search, reported that he found nothing believable. Dr. Timothy Spar, former MPC director, emphasized that uncertain or poorly understood recoveries could distort predictions. Something unacceptable for an object with this level of importance. For that reason, no reliable recoveries were identified from its 2020 or 2016 orbital passes. One candidate from 2018 was rejected because the object's reported magnitude was about 29, far too faint for the telescope that supposedly detected it. However, on January 17, 2025, Dr. Larry Deno and Dr. John Tonry found a weak, trailed recovery in an Atlas Chile image taken on December 25, 2024, just 2 days before the asteroid's discovery. They pinpointed the spot by calculating where the asteroid should appear in earlier images, and then manually searching for a faint streak. Though it was only a single frame and faint, Dr. Marco Micheli later verified it, and the observation helped refine the asteroid's orbit. End of the first lunation. As 2024 YR4 started to fade from view because of the first full moon after its discovery, Dr. Farnakia told Dr. Fass that he expected the asteroid's impact probability could climb to around 1% sometime in late February or early March. This estimate came from Monte Carlo samples generated using the current orbital uncertainty, He also created a graphic showing that there was about a 70% chance the impact probability would rise above 1% as more observations were added. In their email exchange, they noted that if astronomers couldn't collect enough data before the asteroid became too faint in April or May 2025, the world would have to wait until 2028 to refine its 2032 impact probability. That meant there would be lingering uncertainty about whether mitigation measures might eventually be needed. Other institutions also ran their own calculations on 2024 YR4. Japan's space agency, JAXA, used its Deep Space Multi-Object Orbit Determination, System D, MOODS, at the May 2025 Planetary Defense Conference. JAXA reported that their results were similar, though slightly lower, compared to other teams throughout the apparition. Climbing impact probability, second lunation. From January 13th to February 12th, 2025, the period leading up to the next full moon, global attention on 2024 YR4 increased dramatically as its estimated impact probability continued rising during this time. The MPC received another 184 observations from about 23 observatories worldwide. The flood of new data was extremely valuable, but it also exposed some challenges in collaborative observing campaigns. Some datasets ended up crowding the information pool, which meant analysts at CNOs, NEOC, and NEODs had to carefully sort through the submissions to make sure that observations with large errors didn't distort the orbit calculations. Some of the newly collected data turned out to be less useful than hoped. A few observatories submitted observations without including error estimates, which meant their measurements had to be downweighted, even though some were otherwise quite good. Others relied on outdated star catalogs, so their results had to be discarded altogether. During the second lunation, the strongest and most reliable data came from these observatories. 1.54M Danish telescope, ESO's 8.2 M Very Large Telescope VLT at Paranal Observatory, 8.1 M Gemini South on Mauna Kea, Hawaii, 2.4M MRO, 2.56M Not at La Palma, Canary Islands, 2.2 MU888, 4.3M LDT, 1M Telescope at Cerro Tololo, Las Cumbres Observatory LCO. According to Dr. Farnakia, the Danish telescope was one of the most productive contributors, providing 53 high-quality observations over 17 nights between the 7th of January and the 6th of February 2025. Drive Marco Micheli agreed, adding that the Danish telescope and MRO effectively became the reference telescopes for the US and European teams through early February. Manos continued gathering astrometric data using the LDT throughout this period and into late February, and the VLT delivered especially valuable measurements as well. Inauguration. The presidential inauguration on the 20th of January 2025 and the temporary federal hiring freeze and staffing adjustments that followed caused some short-term disruptions for government workers. However, this had almost no impact on the global planetary defense effort. The only challenge was the usual coordination on who NASA should notify within the US government, which NASA leadership handled through interagency meetings. Further physical characterization and astrometry. Dr. Maxime Devahole, a physical characterization scientist at NEOCT, learned about the importance of 2024 YR4 on the 7th of January 2025 and immediately joined the characterization work. Using the 3.58 MTNG at La Palma, he obtained color measurements. He also noted that the VLT delivered both physical characterization data from M. Devahole and O. Hainaut and high-quality astrometry that helped push the asteroid's impact probability to 1%. According to him, the VLT remained highly responsive throughout the entire 2024 YR4 observation campaign. Dr. Devo Gailey submitted a proposal for near-infrared observations on the night of the 19th of January 2025, received approval on Monday, and by the next morning, the 21st of January, the VLT had already collected the NIR data needed for deeper characterization. Additional physical characterization progress came around the 27th of January 2025. Dr. Devigel combined Mount Lemmon at 52 observations from 27, the 28th of December 2024 T. Buden LDT data from the 7th of January N. Moskowitz and VLT data from the 21st of January P. Pravec. This allowed him to phase the rotation period from discovery through that date and extend the light curve. Data from both the VLT and the Danish telescope at Lucilla showed a rotation period of roughly 19.5 minutes. Additional characterization work came from director's discretionary time DDT observations using the 8.1M Gemini South telescope with its GMO spectrograph on the 7th of February 2025, and from Keck-IZEM SFIRE instrument on the 12th of February 2025. These data helped T. Ballin and colleagues derive a full spectrum of the asteroid based on an absolute magnitude of 23.9, 0.3, and assuming an albedo between 0.15 and 0.4. They estimated 2024 YR4 size to be between 30 and 65 meters. They also confirmed the previously measured rotation period and added color photometry, partial spin vector information, and shape analysis, concluding that the asteroid has an oblate form. Informal collaborative efforts. As the impact probability of 2024 YR4 continued to rise, both official and unofficial networks started forming. On the 17th of January 2025, researchers created an informal Slack channel to bring together orbital experts, astrometrists, physical characterization scientists, and mitigation specialists. The idea was to collaborate more quickly and efficiently than email allowed. This Slack space became a useful tool for coordinating what began as an informal observing campaign. Importantly, it didn't replace official communication channels. Those still handled the formal exchange of information according to NASA policies and IIWA agreements. Instead, it supplemented them. Participants in the Slack group also stayed in close contact with PDCO, IAW, and ESA, and were careful about what information they shared. IOWM is now considering whether future events that reach Torino-scale thresholds might benefit from a more formalized communication channel like this one. IOWM has since tested a similar communication channel during the recent 2025 A22 Torino Scale 1 event, and ESA is developing its own plans to expand collaborative tools. Beyond the Slack workspace, many non-governmental groups and private individuals contributed to different aspects of the 2024 YR4 response. In an interview with the PDCO, Dr. Marco Micheli emphasized that early observations from amateur astronomers should not be overlooked. For instance, why? Ikari's observations during the initial confirmation phase ultimately proved reliable. Members of the B612 Foundation also played a notable role in these informal information networks. B612 co-founder Rusty Schweikart alerted several colleagues about the potential importance of 2024 YR4. This is how Dr. Andy Rivkin first heard about the object on the 14th of January 2025. Drive Rivkin then contacted PDCO's Dr. Fast to discuss the possibility of submitting a JWST observing proposal, which he was encouraged to pursue. Other informal lines of communication included direct phone calls and emails among researchers who frequently share information on noteworthy near-Earth objects. For example, Czech astronomer Dr. Petr Pravec and Goldstone radar specialist Dr. Lance Benner exchanged emails about 2024 YR4 in early January 2025. Although the timing made radar observations impossible, their correspondence illustrates the value of both informal and formal networking within the planetary defense community. Dr. Rivkin described this network building as part of a virtuous cycle that continually strengthened throughout the 2024 YR4 event. Cooperation between US and European colleagues was especially helpful in shaping a successful JWST proposal and later analyzing the spacecraft's data. Email remained the primary communication method across both formal and informal channels, supplemented by the Slack workspace. Approaching the 1% impact probability threshold. As additional observations were submitted to the MPC, CNEOS, NEOCC, and NEODIS continued to compute impact probabilities. Although the three centers use independent algorithms and procedures, they frequently cross-checked one another's reasoning and data inputs. During this period, several earlier observations were resubmitted to the MPC with improved measurements and uncertainty estimates. And some observers requested deletions of older data because the MPC was in its prep mode, a phase in which deletions are not normally processed. They were initially unaware that 2024 YR4 had become a Torino scale level, one object when the first replacement requests arrived. Once the significance became clear, MPC staff responded quickly and processed these revisions manually. They are now evaluating updates to streamline immediate replacements and deletions in the future. Replacement data also created challenges for the NEOFIXER system, which prioritizes global observing tasks in submission order. Work is underway to improve how NEOFIXER handles such updates. NEOFIXER is still being improved to better manage special situations that require updated or replacement observations. At first, it treated 2024 YR4 just like any other small asteroid. Each of the three orbit calculation centers posted their predictions online, and CNEOS added the object to the Sentry system. Orbit specialists faced the ongoing challenge of sorting the most trustworthy observations, downweighting data without uncertainty estimates, and removing entries based on outdated star catalogs. On January 21, 2025, CNEOS calculated that 2024 YR4 had a 0.55% impact probability IP and an estimated diameter of 90 meters. Unusually, the IP wasn't decreasing as more data came in. Updated figures soon followed. CNEOS found 0.5%, NEOCC reported 0.99%, and NEODIS calculated 0.89%. In an email to the PDCO, Dr. Farnacki explained these numbers and predicted the IP would likely continue rising as the orbit was refined. Internal NASA notifications. On January 22, 2025, Dr. Fast emailed NASA's Planetary Science Division Acting Director, Dr. Charles Webb, to alert him that 2024 YR4, estimated at roughly 56 meters in diameter, had a low but non-zero chance of impacting Earth on December 22, 2032, with potential for localized damage. He noted that the object could cross NASA's 1% impact probability reporting threshold within weeks and might attract public attention even sooner. After additional discussions that day among CNEOS, NEOC, and NEODIS, Dr. Paul Chodas warned that the IP might climb as high as 4 to 5% before hopefully dropping to zero. Lindley Johnson pointed out that this would be the most significant close-approach threat since Apophis in 2029, and lamented the lack of planetary radar. The world's most powerful radar instrument, Arecibo, had been destroyed in December 2020, leaving no comparable system to refine the asteroid's size and shape. Mitigation studies. Some teams began running preliminary impact risk and mitigation simulations during this period. However, because the IP and Torino scale rating were still low and could shift quickly with new data, the PDCO advised that NASA would not publicly discuss any mitigation concepts yet. Torino Scale 3 notifications. Impact probability approaches 1%. Early informal discussions begin. In the following days, still within the second lunation, the impact probability continued to rise. According to Dr. Devagel, the 8-meter VLT delivered extremely precise observations on January 21st, 2025. Once these data were incorporated, the IP edged even closer to the 1% threshold. By January 23rd, one day before NASA representatives were scheduled to appear on a planetary defense panel at the Sundance Film Festival, the IP was nearly 1%. Dr. Fast prepared to coordinate remarks with ESA's Richard Moyesel if media questions arose, ensuring that NASA and ESA would present aligned messaging. Throughout this period, CNEO, ETSE, and EODS agreed to cross-check each other's reasoning and data selection, but without altering their independent computational methods to ensure everyone understood which observations were being trusted and why. On January 27, 2025, Dr. Farnakia informed Dr. Fast and Lindley Johnson that CNOS, NEOCC, and NEODIS had independently reached the same conclusion. The impact probability had exceeded 1%. This automatically elevated 2024 YR4 from Torino Scale Level 1 to Level 3, the highest rating assigned to any object since Apophis. At that time, the asteroid was estimated to be about 60 meters in diameter within a 40 to 90 m range, placing it in the Torino 3 category, which applies to objects larger than 50 m with an IP above 1%. This made the 1908 Tunguska event a useful reference point for potential consequences. A Torino 3 rating indicates that the event merits attention from the public and public officials if the predicted encounter is less than 10 years away. PDCO staff monitored updates on the CNEOS and MPC websites, which, also for the first time in several years, displayed special banners and color coding marking a Torino Scale 3 object. PDCO concluded that 2024 YR4 met all criteria for initiating the full notification procedures required under NASA NPD 8.740.1, as well as the IAWN notification protocol. That same day, acting in her role as IAW coordinating officer, Dr. Fast alerted the IAW steering committee and permanent observers that she would soon convene a meeting concerning Risk List Object 2024 YR4. The recipients included Michael Zolnowski, Dr. Alan Harris, Dr. Boris Shustov, Dr. Richard Moissel, Dr. Detlef Koshny, Dr. Gonzalo Tancredi, and Romana Kuffler. On the morning of January 28, 2025, Dr. Fast sent an informal advance notice to IAWN's signatory points of contact, explaining that the asteroid's impact probability had passed the 1% threshold and reached Torino Level 3. She noted that once the numbers were officially confirmed, IAWN would issue formal notifications to SMPAG and UNOOS. Impact probability reaches 1%. NASA and FEMA begin formal notifications January 28, 2025. That evening, Dr. Fast informed Dr. Nicola Fox, Associate Administrator of NASA's Science Mission Directorate, that the notification threshold had been crossed. Dr. Fox instructed her to proceed with the formal notification process under NPD 87401. At 8:56 p.m. EST on January 28, 2025, Dr. Fast began issuing the required notifications. These were sent to NASA Acting Administrator Dr. Janet Petro, SMD Associate Administrator Dr. Nicola Fox, PSD Acting Director Dr. Charles Webb, NASA OIR Director Dr. Margaret Kiefer, additional NASA HQ staff Elaine Denning, Kevin Connell, Andrew Rowe, Karen Fox, Molly Wasser, Josh Handel, JPL/C NEOC NEOS Director Dr. Ryan Park, FEMA Representative Michael Manchester. The notification email explained that Torino Scale 3 signifies a close approach that warrants attention from astronomers. Current calculations show a 1% or greater likelihood of an impact capable of causing localized destruction. It also noted PDCO's responsibilities under NASA policy and IIW agreements, including notifying UNOOSA on behalf of IIW and informing SMPAG, which coordinates international planning for any space-based response. Please find attached the notification sent by the Planetary Defense Coordination Office PDCO, issued in accordance with NASA Policy Directive 8740. 1. Notification and communications regarding potential near-Earth object threats, which outlines the required responsibilities for timely reporting. The attached document includes the most up-to-date information on the potential asteroid impact threat, as assessed by the JPL Center for Near-Earth Object Studies, CNEOS, and the PDCO. This is an actual event, not a drill. The notification has also been distributed to the interagency contacts coordinated with OIR to ensure full compliance with Directive 8740. Interagency notifications. At 8:57 p.m. EST on the 28th of January 2025, Dr. Fast sent a notification email to the Office of Science and Technology Policy Lisa Friedersdorf, NC/E/O, P. Augusta Binns Berkey, FEMA Michael Manchester and Jeremy Greenberg, U.S. Space Force Mr. Merrick Garb and Brigg, General Jesse Morehouse, and the State Department Ryan Guietta. The message provided details regarding the potential asteroid impact with a 1.2% impact probability, in accordance with NASA PD 8740. 1. And included NASA/OIR and Public Affairs on the distribution. On the morning of the 29th of January 2025, NASA senior leadership, including Acting Administrator Janet Petro and Associate Administrator Nicola Fox, held a Microsoft Teams briefing with representatives from FEMA, the Department of Defense, and OSTP. They informed these agencies about the asteroid's Torino scale rating of 3 and advised that PDCO would provide additional updates to their respective staff, media, and public communications. Also on the 29th of January, Lindley Johnson reached out to several non-NASA organizations, requesting that their public messaging remain consistent with NASA's official statements. He emphasized that publishing projected impact corridors was premature due to large uncertainties and because the asteroid's impact probability was expected to decline. Throughout the following 4 weeks, NASA, ESA, and other members of the planetary defense community handled media inquiries and interviews, resulting in over 75 news reports from both mainstream and specialized outlets. Several U.S. organizations and individuals contacted NASA for guidance to ensure their statements matched NASA's public information. That same day, NASA also used its Asteroid Watch account on X to notify the broader global planetary defense network and the public. As Josh Handel explained, Asteroid Watch functions as an operational information channel aligned with national and NASA strategies, issuing timely updates on NEOs expected to impact or pass close enough to warrant public notice. This account continued to share updates on 2024 YR4 as its impact probability evolved, with each post receiving hundreds of thousands of views. Formal IAWN and interagency notifications, the 29th of January 2025. Following the acting administrator's morning briefing, Dr. Fox instructed Dr. Fast to proceed with the next steps in the formal notification process. To advance the ION notification process, Dr. Fast and Lindley Johnson spent the 29th of January 2025 collaborating within NASA and with the IAWM Steering Committee to refine and harmonize the language for the official IAW message. At 9:23 p.m. ST, Dr. Fast sent a formal email to you, NOOSA, Miss Romana Koffler and SMPAG Dr. Detlef Koshny, reporting the impact probabilities calculated independently by CNEOS, NEOCC, and NEODs. She also informed the IAW's signatory points of contact that an official notification had been issued, marking the first real-world non-exercise alert ever released by IAWNA. The message described 2024 YR4 as being between 40 and 90 meters, 130, 300 feet in size, with a then current impact probability of 1.3%. The notification followed the criteria established in UNCOPUOS document /AC.1/2017/C-RP.25, which requires IAWN to issue warnings for objects larger than 10 meters whenever the predicted impact probability exceeds 1%, or when brightness-only data suggest an absolute. While as paused, Dr. Fast also ensured that all observers expected at the upcoming the 4th of February 2025 and received this information in advance, guaranteeing broad awareness of the Asteroid Scale Level 3 status. Areno Scale Level 3 status. Earlier that same afternoon, at 4:09 p.m. EST on the 29th of January 2025, Dr. Fast distributed a separate interagency notice under the 2023 National Strategy and Action Plan for Near-Earth Object Hazards and Planetary Defense. This email, containing the same technical attachment, was sent to representatives across the USF, U.S. Space Command, the National Reconnaissance, OAA, NSA, the Executive Office of the President's OMB OSG SEDI, and additional NASA. Please see the attached notifications sent by NASA's Planetary Defense Coordination Office PDCO and shared here in accordance with the National Strategy and Action Plan for Near-Earth Object Hazards and Planetary Defense. I am sending this to the distribution used for the most recent Planetary Defense Interagency Working Group meeting. The attached document includes the latest assessment of a potential asteroid impact threat as reviewed by the JPL Center for Near-Earth Object Studies, CNEOS and PDCO. This is not an exercise. Public messaging. NASA deliberately avoided issuing extensive public statements during this early phase, aiming to prevent unnecessary alarm, as the impact probability was expected to decrease with continued observation. Meanwhile, as media outlets began reporting on 2024 YR4, Dr. Richard Meisel informed Dr. Fast that ESA was receiving heavy press interest. Working closely with PDCO, he coordinated a unified communication strategy and circulated guidance to European partners. He referred them to ESA's FAQ page, which emphasized, share only verified, current information and avoid speculation or premature conclusions. highlight that an impact probability of around 1% still means roughly a 99% chance of no impact. Make it clear that the current dataset is still pretty limited, but we're rapidly collecting more observations with the right instruments to get a clearer picture as quickly as possible. IAWN is in the process of pulling all the information together and will share an updated statement soon with input from its member organizations. We're working non-stop to gather additional data, reassess the situation in real time, and provide new updates as soon as they're available. NASA also began receiving press inquiries, something that only increased over the following weeks as the impact probability continued to rise. In response, NASA's Senior Science Communications Officer prepared a blog post outlining the essential details about 2024 YR4. After internal review, it was published on the 29th of January 2025. UNOOSA notification to UN member states. On the 30th of January 2025, UNOOSA, acting as the Permanent Secretariat for SMPAG, issued a formal notice to UN member states about Asteroid 2024 YR4, which had surpassed the 1% impact probability threshold for a potential event on the 22nd of December 2032. The alert even reached the UN Director General's attention, something that rarely happens. Mitigation analysis and risk assessments. SMPAG's recommended criteria for starting to plan mitigation missions are: impact predicted within 50 years, an impact probability above 1%, and an estimated size larger than 50 meters. These guidelines, however, are not strict rules. In this case, NASA and the PDCO recognize that performing detailed, location-specific risk assessments at only till 1% probability would have been misleading, especially since the asteroid still had a wide range of possible paths, most of which posed no danger. Because of this, notifications included only broad, general information about potential impact regions, avoiding any specific risk corridor. NASA did not want to suggest a precise impact path unless the probability increased significantly while the asteroid was still observable. NASA concluded that serious mission planning discussions could reasonably wait until late April or May, once the observing window had ended and all possible data had been collected. SMPAG agreed with this approach and opted not to activate formal mitigation planning yet. Instead, they would monitor how the risk evolved and reconsider if new data pushed the probability higher. At its 24th meeting on the 5th of February 2025, SMPAG stated, SMPAG will continue to closely monitor changes in impact probability and new information about the object's size. While initial discussions have begun, it is still too early to outline any specific space mission recommendations. This will be re-evaluated at a later meeting, likely near the end of the visibility period around late April or early May 2025, or sooner if circumstances require it. If sufficient data could not be gathered before the end of the apparition in April 2025 or in May, with support from space-based telescopes to adequately constrain the orbit, mission planning would still have remained an option. Although a formal mission planning effort was never initiated for 2024 YR4, individual researchers and institutions began conducting impact risk assessments and preliminary mitigation analyses in anticipation of a potential rise in the impact probability. These efforts involved Dr. Lorian Wheeler and Dr. Jesse Dotson of NASA's Asteroid Threat Assessment Project ATAP, as well as Dr. Brent Barbee, the Planetary Defense Applications Lead at GSFC, who evaluated possible mission concepts for both reconnaissance and deflection. Internationally, JAXA explored whether the Hayabusa 2 spacecraft could theoretically be repurposed to attempt a deflection of 2024 YR4, examining potential trajectory solutions. At the 2025 Planetary Defense Conference, JAXA presented this study along with a proposal for deploying a constellation of 12 spacecraft in an asteroid flyby-cycler orbit, capable of performing monthly NEO-flybys for reconnaissance and possible deflection operations. On the 30th of January 2025, Dr. Farnokia informed the PDCO that preliminary reductions of new astrometry from Marco Micheli suggested the impact probability might increase to roughly 1.5%, based on additional images identified by CSS. Meanwhile, Dr. Andy Rivkin explored whether NASA's Hubble Space Telescope could extend observations of the object into May as it progressed along its orbit. The 4th of February 2025, 20th meeting of the IAON Steering Committee. On the 4th of February 2025, the IAON Steering Committee held its annual meeting in Vienna, Austria, coinciding with the UNCOPUOS Scientific and Technical Subcommittee session, with additional participation from IIWN signatories both in person and online. The meeting proved highly valuable for coordinating observations and responses related to 2024 YR4. DriveFast noted that had the meeting not already been scheduled, a dedicated meeting would have been convened specifically for this purpose. The session included briefings on 2024 YR4 from DriveFast updates and communications, Dr. Farnokia orbit determination, Dr. Marco Micheli discovery, recovery, and early follow-up, Dr. Maxime Devogli physical characterization, Dr. Federica Spoto MPC involvement, Dr. Alex Gibbs CSS/Neofixer, and Dr. Detlef Koshny Sempag. Dr. Fast advised members to coordinate any public communication through their respective public affairs or communications offices, or, if such offices were not available, through NASA or ESA, and to avoid speculative statements or speaking on behalf of other signatories. She also emphasized that this marked the first time the UN had received an official notification from IAWN for dissemination to member states, achieved through the UNOOSA circular mentioned previously. Presenters, including Dr. Farnokia, Dr. Micheli, and Dr. Devogli, shared early lessons learned and guidance for ongoing efforts. Several astronomers later noted that these insights helped shape their subsequent activities. For example, they stressed that coordinating observations among 2 or 3 observatories at any given time was ideal. Relying on only one could introduce bias, while involving too many could complicate orbital refinement and inefficiently use resources. Figure 5. Statistical assessment of the potential evolution of the impact probability, assuming 50 millirexicon astrometric precision left, and the likelihood of future impact probabilities right for 2024 YR4, as presented by Dr. D. Farnokia on the 4th of February 2025 at the 20th meeting of the IAW Steering Committee. As the impact probability rose to 1.9%, the community continued exploring additional methods for improving the orbital solution. On the 6th of February 2025, Dr. Mwassel, on behalf of ESA, contacted Dr. Fast to inquire about the possibility of using NASA's Lucy spacecraft, currently tasked with exploring multiple Jupiter Trojan asteroids, to obtain imagery of 2024 YR4. The Lucy team performed a preliminary feasibility study and concluded that such observations were technically possible, but carried substantial risk and would require considerable resources to investigate further. Additionally, CNEOS determined that the potential tenfold improvement in orbital accuracy that Lucy might provide could instead be achieved through ground-based observations over the next month, supplemented by possible JWST observations. Consequently, no formal request was made to employ Lucy for this purpose. Impact probability peaks at 3.1% before declining to a negligible level. Astrometry during the third lunation, the 12th of February, the 14th of March 2025. As 2024 YR4 continued to dim, only the largest telescopes were capable of obtaining the high-quality observations needed during the period between the second and third full moons. These facilities included the 8.1M Gemini North T15, 10M WM, Keck Observatory T16, 8.2M Subaru Telescope T09, and 3.58M Canada-France-Hawaii Telescope CFJT T14, all located on Mauna Kea, Hawaii. Additional observations were provided by the 8.1M Gemini South I-11 on Cerro Pachun, Chile, the 5.08M Hale Telescope at Palomar Observatory, California 675, the 2-meter twin telescope in the Canary Islands Y68, functioning as an effective larger virtual telescope, and the Large Binocular Telescope LBT on Mount Graham, Arizona G83, whose two 8.4M mirrors operate together as a single large aperture system. Other facilities, LDT 4.3M, not 2.54M, MRO 2.4M, and UH88 2.2, also continued to contribute imaging data. Notably, MRO succeeded in imaging the object at magnitude 25.5, surpassing its previous expected faint limit of magnitude 24.5. These exceptionally faint detections, still obtained with low uncertainty, continued as late as the 28th of February 2025. A visualization created by Dr. Micheli and Dr. Farnokia highlights the progression of observations collected throughout the object's apparition. Figure 6, sequence of observatories contributing data as 2024 YR4's apparition steadily dimmed D. Farnakia, and M. Micheli. Impact probability peaks at 3.07% before declining. On the 18th of February 2025, CNEOS updated the impact probability using a single observation from NOT on the 15th of February 2025 and another individual measurement from MRO. This update showed the probability briefly reaching 3.1%, with NEOCC estimating 2.8% and NEODs 2.3%. Later that evening, Dr. Farnakia notified the PDCO that new astrometric data from LDT suggested the probability would decrease to 2.5%. Additional observations the next day caused the probability to decline even further, and by the 20th of February 2025, it had dropped to well below 1%. CNEOS informed the PDCO that their simulations indicated the probability was unlikely to rise again. High-quality follow-up observations continued from MRO, NOT, CFH-T, and the LBT, to illustrate the decreasing uncertainty and how the range of possible orbits was shifting away from Earth. Dr. Farnakia generated an animation with its first and last frames shown below. Closure notifications following the drop in impact probability. After the impact probability decreased, IAW and NASA and ESA issued follow-up notices confirming to the global community that new observational data definitively showed 2024 YR4 no longer posed a threat to Earth. On the 24th of February 2025, Dr. Fast distributed the required notifications to NASA and interagency stakeholders, reporting that the impact probability had fallen to 0.004%, eliminating any meaningful chance of a future impact. Acting as the IAAO coordinating officer, Dr. Fast also sent the updated information to UNOOSASMPAG and to all IAO and signatory points of contact and observers who had received earlier updates. Success in refining the impact probability. The acquisition of sufficiently high-quality observations to significantly reduce the orbital uncertainty of 2024 YR4 was a major achievement, ultimately enabling experts to rule out the possibility of an impact. With the new observations, scientists were able to rule out any chance of an Earth impact on the 22nd of December 2032. Earlier, several astronomers had cautioned that the impact probability might stay above 1% as the asteroid dimmed and became harder to observe, making the decision-making process more complicated. This scenario could indeed have occurred if the asteroid's path had been closer to, or directly on, an impact trajectory. However, the steady flow of high-quality measurements submitted to the MPC ultimately revealed that 2024 YR4 would safely miss Earth. On the 25th of February 2025, news outlets around the world reported that NASA and ESA had officially declared the asteroid no threat. JWST stepped. Beside the fact that the impact probability had already dropped well below 1%, the JWST director's discretionary time request, approved earlier, was kept in place to demonstrate JWST's capabilities for such targets. On the 8th of March 2025, JWST captured near-infrared images with NRCam. A common technical issue prevented the use of MR5 for mid-IR data, so although the observations provided helpful astrometry, they did not further refine the asteroid's size. A second opportunity for MIRI observations was planned for the following lunation. Characterization. During this phase, the NOT served as a bridge between smaller telescopes like the Lacilla Danish telescope and the large facilities needed later on. In the second half of February, NOT contributed key images for physical characterization, including light curve data, and continued to supply valuable astrometry as the asteroid grew fainter. Additional photometry came from the VL Not and the LBTA Junta, with Gemini North providing more light curve measurements toward the end of the period Aber-Donoff. Aftermath. Fourth lunation period, the 14th of March, the 12th of April 2025. In this next window between full moons, only the VLT-22, the 23rd of March 2025, and JWST, the 26th of March, Rivkin et al., were able to gather observations of sufficient quality for astrometry. The VLT observed 2024 YR4 at magnitude 26.5, the faintest ground-based detection as of the 12th of May 2025. On the 26th of March 2025, JWST successfully obtained MIRI data, which allowed scientists to refine the asteroid size estimate to 67 meters, narrowing the earlier 40 to 90 m range and confirming that an impact would have caused regional to local scale devastation. Based on the size constraints and albedo, Dr. Devigel suggested the asteroid is most likely an L-type, darker than typical S-types, though an S-type cannot be ruled out. Dr. Peter Jeniskins proposed that 2024 YR4 might be an H-chondrite, with a small possibility of being an L-chondrite. By this stage, the asteroid's Earth impact probability had already fallen to negligible levels, but its lunar impact probability increased to 3.8%. Although IAW and PDCO are not mandated to track potential impacts on the Moon, additional observations may still be pursued for scientific purposes and to assess potential effects on cislunar and geostationary belt technologies. Later lunation periods. After the 12th of April 2025 full moon, the asteroid had become too faint for any further ground-based observations, leaving JWST as the only instrument capable of collecting additional astrometric data. Imaging was carried out in mid-May 2025. According to Dr. Rivkin, NRRCam successfully obtained images, but observations with MIRI were again halted due to guide star acquisition problems. Although the size could not be further refined, one additional position measurement from the 11th of May was recovered from the data and submitted to the Minor Planet Center. On the 3rd of June, CNEOS notified PDCO that this extended orbital arc slightly increased the lunar impact probability to 4.3%, the last adjustment possible during the asteroid's current apparition. For future apparitions, NASA's Hubble Space Telescope may be able to observe the object, an option already being assessed by Dr. Tony Roman and Rob Landis. Even though no formal mission planning activities were initiated, several informal teams continued evaluating potential mission concepts. The Asteroid 2024 YR4 is now being included as a scenario for future exercises, including those conducted by the Interagency Modeling Working Group MWG composed of NASA, NSA, NNUSG PD Mission Analysis, and Research Group at GSFC studied what mission options might have been viable had the impact probability continued to increase, identifying capability gaps in both U.S. and international response. Their analysis suggested that a reconnaissance mission could, in principle, have been launched in December 2025, reaching 2024 YR4 in February 2027, well ahead of the asteroid's December 2028 close approach to Earth. Ideally, such a mission could serve both reconnaissance and potential mitigation roles, consistent with Section 3.1 of the National Preparedness Strategy and Action Plan for Neo-Hazards and Planetary Defense, which states that rapid response reconnaissance missions should consider deflection or disruption capabilities as well. However, Dr. Barbie, who led the study, emphasized that with current technology, executing such a rapid response mission within that tight timeline is not realistically achievable. Lessons learned. The discovery, follow-up observations, orbital refinement, notification processes, and physical characterization of 2024 YR4 yielded numerous insights, some highlighting strengths of the planetary defense system, others revealing areas in need of improvement. Alerts and coordination. Managing the trade-off between issuing alerts early enough for observers to respond and avoiding excessive false alarms remains a core challenge in planetary defense. For 2024 YR4, NASA could not confirm a Torino Scale Level 1 classification until observations collected on the 29th of December 2024 were processed by the MPC and analyzed by CNEOS. Astrometric Community. The PDCO learned on the 31st of December 2024 that 2024 YR4 had reached Torino 1. Shortly after the late December observations provided sufficient data for a reliable probability estimate. The astrometric community, routinely monitoring Sentry, judged that enough time remained through April or May 2025 to track the asteroid. By the 23rd of February, after the impact probability peaked at 3.1% on the 18th of February, sustained high-quality observations succeeded in reducing the IP to a negligible level. Physical characterization community. Unlike the astrometry community, researchers focused on physical characterization do not typically monitor Sentry in real time. As a result, some teams may have had opportunities for earlier data acquisition had they been alerted sooner. Early physical characterization can substantially inform later risk assessment and mission design. Although radar, polarimetry, and IRTF observations were missed, other assets did provide critical characterization data. The PDCO is now evaluating methods to enhance early notification for the physical characterization and radar communities through IAWN. Accelerating such alerts would increase opportunities for early light curve measurements, high-precision astrometry, and other data when targets are brightest and closest to Earth. Potential improvements under consideration include creation of an automated Sentry API that pushes alerts for Torino 1 objects, establishing a persistent IAWN Slack channel for real-time updates, initiating earlier internal notifications of Torino Level 1 events to key IAWN stakeholders, and other streamlined communication mechanisms. PDCO, working with the IAON administration team at the University of Maryland and with NeoCC, has already tested some of these concepts using Asteroid 2020-25 FA22, which briefly reached Torino 1 on the 25th of April 2025 before returning to Level 0. IAWN also ran an experimental Slack channel for that event, providing a practical testbed for real-world coordination. As additional procedures are refined, PDCO, through its role in coordinating IAWN, and will ensure that updates are broadly disseminated across the planetary defense community. C. Survey community. Observatories that conduct follow-up NEO observations were generally better informed about 2024 YR4's importance than the survey observatories, whose primary role is discovery rather than extended tracking. Similar to the physical characterization community, survey teams do not routinely monitor Sentry, which is mainly intended to prompt follow-up observations. Nevertheless, survey facilities can play a crucial role early in the process by providing recovery data, archival observations that significantly improve orbit determination. LS astronomer Larry Deno noted that although he submitted the initial discovery data for 2024 YR4 to the MPC, he was unaware of its importance at the time and did not see the Sentry alert. He suggested that early notifications, such as an email to the IAWN distribution list identifying objects needing special attention, could accelerate the search for recovery images. Such data can quickly determine whether an asteroid is likely to cross impact probability thresholds that warrant large aperture follow-up observations or space-based assets. NASA is examining ways to notify survey teams about Torino scale 1 objects through IAW and has already tested this approach with Asteroid 2025 FTA22, including methods to alert observatories that may hold relevant archival images. D-Orbit analysts Dr. Park noted its D-Orbit Analyphites. Dr. Park noted that communication between orbit analysts and observers was especially effective. Observers rapidly shared their measurements, enabling independent data reductions by others. Over the past decade, the quality of observational data used for orbit determination has steadily improved, and the orbit determination models performed exceptionally well for 2024 YR4. Training experts with the advanced mathematical and analytical capabilities needed for highly precise NEO orbit determination remains a significant challenge, and the pool of individuals with these specialized skills is very small. When the January wildfires forced a temporary shutdown of JPL and required most CNEOS orbital analysts to evacuate, operations were severely disrupted. Even so, Dr. Farnakia continued carrying out essential orbital computations remotely from Idaho through both the holiday period and the wildfire emergency, providing indispensable, though single-point, support to the planetary defense community. Minor Planet Center MPC. The MPC functions as the primary repository for neo-astrometric observations, but its staff does not monitor Torino-scale classifications or perform long-term Sentry-scale impact probability analyses. Those responsibilities lie with CNEOS, NEOC, and NEODIS. Consequently, receiving notifications when an object reaches Torino scale, one could help the MPC anticipate operational needs, such as preparing for potential manual observation updates or adjusting workflows. MPC staff also noted that for high-interest objects, they often receive many repetitive queries, issues that could be streamlined with a dedicated chat or coordination channel for urgent, targeted communication. Finally, due to limited staffing, the MPC cannot operate on a 24/7 basis and is investigating greater automation to handle the substantial increase in observational data expected from next-generation survey systems. C. Survey community. Facilities responsible for follow-up NEO observations were generally more aware that 2024 YR4 was an object of interest than the survey observatories, whose primary task is to detect new objects rather than continue tracking them. Similar to the physical characterization community, survey teams do not routinely monitor the Sentry system, even though Sentry is intended to prompt additional observations. Nevertheless, survey observatories can still play a crucial role in the early phases of NEO assessment and orbit improvement. particularly when they recognize the importance of an object early and can supply valuable recovery data. Atlas astronomer Larry Deno noted that he transmitted the initial discovery observations of 2024 YR4 to the MPC, but was not aware of their significance at the time and did not notice the Sentry alert. He suggested that early targeted notifications, such as an email to key stakeholders, including the IAW distribution list, about objects requiring extra attention could accelerate the search for recoveries. Faster identification of such data may help determine sooner whether an asteroid is likely to surpass impact probability thresholds that justify deploying major follow-up observatories or space-based assets. NASA is currently evaluating methods to notify the survey community via IAW whenever an object reaches Torino Scale 1 and has already tested such an alert for Asteroid 2025 AA22. This effort also involves exploring ways to notify observatories that might hold relevant recovery images. Department of Defense DoD. The Department of Defense possesses assets that, under certain circumstances, could provide supplemental data for objects such as 2024 YR4, ensuring early notification of key DoD liaisons, who can request additional astrometric or characterization support when needed, is part of NASA PDCO's ongoing efforts to strengthen interagency collaboration. IAWN. IAWN issued notifications to SMPAG and UNOSA as required once the object's impact probability IP rose above 1%, and again when it subsequently decreased. UNOSA then informed member states according to established procedures. Regular weekly meetings between US and European partners each Monday proved highly valuable, along with the dedicated IAW meeting on the 4th of February 2025. Service Pay 5. Sunsext We5. IAW also helped coordinate observers through an online coordination platform, which Dr. Melissa Brucker noted was especially useful for avoiding scheduling conflicts and improving observatory time efficiency. Internal NASA and interagency notifications. These communications were carried out in accordance with NASA Policy Directive 87401. Following this real-world event, some updates were made to refine distribution lists and ensure the most relevant recipients were included. 2. Public relations. The public communication surrounding 2024 YR4 was largely considered successful, thanks to transparent information flow and the reliable updates provided by NASA and ESA. By coordinating a unified message for public release, both agencies minimized confusion while keeping any delays in communication to only a few days. Their approach aimed to balance the risks of sharing unconfirmed data, potentially causing unnecessary alarm, against withholding information, which could diminish public confidence. Some internal feedback suggested that certain organizations did not receive full public acknowledgement for their early contributions due to the emphasis on message consistency. Nevertheless, an analysis of 70 major news articles showed that NASA, ESA, JPL, and CNEOs were prominently recognized. A common inquiry from journalists involved the fluctuating impact probability, but clear and consistent explanations helped the media understand why those values changed over time. Although the planetary defense community was mindful of the possibility of sensational reporting or disinformation, only a small portion of articles displayed such issues. One notable case involved an amateur scientist publishing an impact corridor map based on legitimate data. A newspaper later reproduced the map inaccurately, shifting the corridor across several countries, after which a few minor outlets repeated the incorrect version. Despite these isolated incidents, most coverage, whether from major or smaller media organizations, accurately reflected the asteroid's low but non-zero impact risk. ESA released some information slightly earlier than NASA, briefly creating the impression among a small number of reporters that NASA was less involved. However, overall media reporting correctly depicted both agencies as fully engaged in evaluating the threat posed by 2024 YR4. Members of the planetary defense community frequently consulted PDCO for guidance on interacting with the media, and a review of more than 900 PDCO emails related to 2024 YR4 shows that responses were generally prompt. Media outlets either worked directly with NASA personnel or relied heavily on NASA-produced materials, resulting in well over 100 news stories. Internally, the release of public information continued to require approval through NASA's established chain of command. NASA is currently examining what types of information related to Torino scale events could be released without requiring higher-level approval beyond the PDCO. This question arises because the underlying data are already publicly available, though not summarized, on the MPC and CNEOS websites. While there is no restriction on sharing raw data, the creation of summary statements or official NASA web updates may benefit from streamlined processes to ensure NASA maintains clear leadership over U.S. information dissemination. One proposal from CNEO suggests that certain basic details could be pre-approved for public posting. These might include the current impact probability from the orbital solution, discovery date, the discovering telescope, essential orbital parameters, approximate magnitude and size estimates, close approach information, Torino scale rating, and anticipated observability windows. 3. Astrometry, data transfer, and orbital estimates. Observers and orbit determination specialists offered several recommendations for handling future situations, similar to 2024 YR4. A. Reporting uncertainties remains essential. The increasing practice among observatories to routinely include uncertainty estimates in their submissions proved extremely valuable for CNEOS, NEOCC, and NEODs in generating stable orbital solutions. Some observers, however, still lacked uncertainty metrics, submitted data with errors or bias, or continued using outdated MPC formats that do not support uncertainty reporting. About 20% of submissions fell into this category. Such observations were sometimes excluded or downweighted due to missing uncertainty data or atypically large errors. Ongoing training is needed to promote full adoption of the Astrometry Data Exchange Standard ADS, which includes fields for uncertainty specification. B. Best practice: use more than one telescope per observing window. Employing multiple telescopes during a single observing period proved useful for identifying biases from specific sites. After this was discussed in the 4th of February 2025 IAWN Steering Committee meeting, additional observatories work to coordinate directly and via tools like NeoFixer. This best practice should continue to be emphasized within the observing community. C. Outdated star catalogs. A few observatories relied on older star catalogs instead of the Gaia catalog, which interviewees identified as the appropriate standard for data submitted to the MPC. In certain instances, not using current star catalogs sometimes required discarding those observations. Continued reminders to rely on up-to-date catalogs would therefore be beneficial. D. Value of pre-awarded telescope time. Several astronomers noted that having pre-allocated observing time was crucial during the 2024 YR4 campaign. For instance, Dr. De Leon was able to collect early January 2025 characterization data because she already had time granted on the 10.8 MGTC under a general proposal for observing NEAs, virtual impactors, and PHA. Observers likewise had awarded time they could have used had they known sooner about the object's importance. That's wasn't, or that's huge actually shouldn't. What each example have? Wealthy just fictional lectures. You can name beat that to me. On the 26th of February 2025, Dr. Bruker activated a 1-hour target of opportunity 2 slot on one of the 10M Keck telescopes, adding valuable astrometry through NASA's Keck partnership. JWST received Director's Discretionary Time DDT for 2080 Time DDT for 2024 YR4, though a concurrent request for standing 2 time was denied. Establishing dedicated planetary defense 2 time on JWST could be extremely helpful for similar future cases. E. Language barriers. Some observatories in parts of Asia continue to face long-standing challenges in reporting observations, due in part to language limitations. Improved communication and collaboration with these sites could substantially expand global ground-based coverage, especially since only 12 time zones from Hawaii to Eastern Europe are currently well represented. F. Precoveries and negative precoveries. Precoveries for these significant events should be vetted by a peer review process to ensure incorrect data is not entered into the MPC. Also, Dr. Deno commented that his team would like to develop software that can help with automating the process of finding precoveries to more rapidly extend the arc for newly discovered asteroids. Negative observations in archival images to rule out an impact could be used as a last resort when the object is no longer observable. However, negative observations are challenging and should follow the corresponding MPC protocol. HTTPs://minorplanetcenter.net/m PCOP/documentation/ negative observation/ negative observation/ G potential for independent and amateur astronomy community contribution. For similar objects, amateur astronomers played a minor role with 2024 YR4, but Dr. Micheli emphasized amateur astronomers are contributing a lot of good work in the planetary defense arena, particularly in immediately following up on objects. He noted the early Japanese amateur observation was good data though observer was not well known. The independent Schiaparelli Observatory spent 4 to 5 hours observing for astrometry as late as the 2nd of February 2025, pushing their telescope to the limit. Dr. Micheli was able to use that data as well. He emphasized that the role in first reaction to objects such as these is still significant among amateur astronomers, and on the holidays, a lot of people are home observing. In August 2016, 2024 YR4 was at magnitude 20.5, which means amateur observers could have seen it then as it crossed the northern sky. Amateur observers may, therefore, have pictures of galaxies that, unbeknownst to them, may have images of 2024 YR4 in them. He noted someone at their home may have a hard drive sitting with 32 images of the object on it. If 2024 YR4 had reached a higher IP, one possible avenue for additional astrometry could have been reaching out to such amateur astronomers for potential recoveries. One good recovery from years prior, Dr. Micheli emphasized, could yield data that could collapse the orbital uncertainties. While this might be very difficult, it is a potential resource. Simulating possible future IPs helped. Throughout the apparition, Dr. Farnakia provided updated estimates not only for the IP but predictions about the likelihood of the IP to rise or decline to various levels in the future. He did this by running simulations on each predicted orbit compatible with previously reported astrometry. These predictions helped the PDCO make better informed recommendations to NASA leadership for spacecraft. NASA's Lucy spacecraft was considered as a possible platform for observing 2024 YR4, but only if such an observation proved both feasible and necessary. It was unclear whether Lucy could obtain measurements of sufficient accuracy, and any attempt would also need to account for the missions approaching the 20th of April 2025 flyby of asteroid Donald Johanson. Some external analyses, not conducted by the Lucy team, suggested that a single observation might reduce the asteroid's B-plane uncertainty from roughly 270,000 kilometers to about 25,000 kilometers or less. However, the Lucy team's preliminary assessment did not confirm this, and they noted that ground-based observatories were likely to achieve comparable precision by the end of the apparition. For that reason, the PDCO did not submit a formal request to the Planetary Science Division. 5. Physical characterization. Unlike the astrometric community, which benefits from coordination tools such as the MPC and NeoFixer, the physical characterization community does not yet have an equivalent centralized system. At the 2025 Planetary Defense Conference, Dr. Divagale proposed creating an MPC for physical characterization to better coordinate efforts, though IAWN is already examining ways to improve collaboration in this area. Even so, there was enough redundancy across facilities to support observations of 2024 YR4. Additional opportunities for future events may come from polarimetry, radar, IRTF, and assets like MRO. For 2024 YR4, most of the essential physical characterization work relevant to planetary defense was completed through coordinated observations by CSS, the Danish Telescope, GTC, LDT, VLT, Gemini South, Keck, and JWS Communication. Within this community often occurs in smaller groups, so expanding coordination mechanisms could improve data collection as the number of observed asteroids increases. Several techniques could have been applied to 2024 YR4, but at only very limited observational windows. A. Polarimetry. Dr. Devaglay noted that polarimetric data from small telescopes would have been possible only within the first 24 hours after discovery. Larger facilities equipped with polarimetric instruments, such as the VLT or not, might have obtained such data if the phase angle had been favorable, but it was not. B. Radar. I. Goldstone radar. If Goldstone radar had been able to observe 2024 YR4, the asteroid's impact probability could likely have been reduced much earlier. but the available window for radar observation was extremely narrow. Goldstone's staff were not informed of the object's importance in time to attempt coverage. According to Dr. Benner, had the team received a simple text alert, and something not currently done, right after the discovery, around the 28th of December 2024, they would likely have tried to observe it and probably would have succeeded. Such a detection could have produced Doppler astrometry and a range measurement with roughly 1.5 kilometers precision if the radar had been focused on the target for most of the observing track. This in turn might have lowered the Torino rating or prevented it from reaching level 1. However, by the 28th of December, the object's significance was not yet established, and the 3 Goldstone operators were away for the holidays, meaning they would have needed direct calls or messages to respond in time. In principle, Goldstone, combined with the optical observations collected by year's end, had the capability to reduce the impact probability to negligible levels, preventing the Torino increase, but the available response time was too limited for this to be realistically achieved. Loss of Arecibo. If the Arecibo Observatory had not collapsed in 2020, it would have been capable of observing 2024 YR4 up to about the 2nd of January 2025 and likely could have prevented the asteroid from ever reaching Torino Scale 3. Dr. Benner noted that Arecibo routinely achieved 4 orders of magnitude improvement in time delay range, accuracy for similar targets. Dr. Petrov, a former Arecibo researcher, likewise believed that Arecibo could have significantly improved the early predictions for the 2032 close approach. Dr. Farnakia explained that by June 2025, even with JWST's final observation from May, the orbital uncertainty for 2024 YR4 was still about 70,000 kilometers. Arecibo alone could have reached that level of precision by the 2nd of January and, with complementary Goldstone radar, reduced the uncertainty to roughly 15,000 kilometers 3 sigma. In short, the degree of certainty eventually achieved after months of optical tracking could have been obtained within a week of discovery had Arecibo been operational. Additionally, it would have provided far better early constraints on any lunar impact probability. See IRTF. The importance of 2024 YR4 was recognized by IRTF astronomers only after the observing opportunity had already passed. Dr. Vishnu Reddy emphasized that IRTF could have collected useful data if physical characterization observers received alerts more quickly. Dr. Christina Thomas, who was observing with IRTF on the 4th of January 2025, had to rely on manual instructions due to a VPN issue and directed the on-site operator to observe only the brightest targets, causing 2024 YR4 to be missed. Had she been operating the telescope herself, her expertise would have allowed her to target fainter objects such as 2024 YR4 on the 2nd of January 2025. She noted that by the 3rd of January, it was likely already too faint. If she had known the asteroid had reached Torino Scale 1, she would have instructed the on-site observer on the 2nd of January to attempt imaging the fainter targets that night. Manos principal investigator Dr. Moskovitz expressed a similar view, explaining that Manos missed the chance to initiate characterization observations, such as those at IRTF, while 2024 YR4 was still bright during the week after its discovery. By the time the physical characterization community began focusing on the asteroid, it was already too faint for IRTF observations. In response, Manos has updated its alert protocols to trigger observations for high-priority objects, now including virtual impactors like 2024 YR4 Torino Scale 1 and imminent impactors listed on the NEOCP Scout Impact Rating .2. These alerts are distributed through a dedicated Manos Slack channel accessible to all team members, which they believe will improve their response time. Additionally, they now have the capability to observe any OCP objects using the LDT and RTF since 2022, enabling more efficient operations during critical events. The PDCO, which funds IRTF, is reviewing how the Time Allocation Committee evaluates proposals related to planetary defense observations. Had she been operating the telescope herself, her expertise would have allowed her to target fainter objects such as 2024 YR4 on the 2nd of January 2025. She noted that by the 3rd of January, it was likely already too faint. If she had known the asteroid had reached Torino Scale 1, she would have instructed the on-site observer on the 2nd of January to attempt imaging the fainter targets that night. Manos principal investigator Dr. Moskovitz expressed a similar view, explaining that Manos missed the chance to initiate characterization observations, such as those at IRTF, while 2024 YR4 was still bright during the week after its discovery. By the time the physical characterization community began focusing on the asteroid, it was already too faint for IRTF observations. In response, Manos has updated its alert protocols to trigger observations for high-priority objects, now including virtual impactors like 2024 YR4 Torino Scale 1 and imminent impactors listed on the NEO-CP Scout Impact Rating .2. These alerts are distributed through a dedicated Manos Slack channel accessible to all team members, which they believe will improve their response time. Additionally, they now have the capability to observe NEO-CP objects using the LDT and RTF since 2022, enabling more efficient operations during critical events. The PDCO, which funds IRTF, is reviewing how the Time Allocation Committee evaluates proposals related to planetary defense observations. 6. Mitigation. Historically, exercises have assumed that mitigation planning should start once an event reaches Torino Scale 1. In reality, this threshold proved too early. Updating training exercises and the guidance behind them to better reflect actual operational experience should be a long-term objective, and Termy Dr. Barbie noted that if another object similar to 2024 YR4 appeared, one on the larger end of the 40 to 90 m size range, fading from detectability, and showing an impact probability above 10% fifth, a faster response would be crucial. He recommended continued development of rapid response missions capable of both characterization and mitigation. Additional suggestions from the risk and hazard analysis communities include discussing the appropriate use of different sigma levels when estimating potential damage. 7. Future technology. A. NEO Surveyor Space Telescope. NEO Surveyor, a dedicated infrared and NEO detection spacecraft planned for launch in or after September 2027, is expected to greatly expand detection capabilities. According to Dr. Park, CNEO's manager, had NEO Surveyor been operational in 2024, it would likely have identified 2024 YR4 in October or November, 1 to 2 months earlier than ground-based discovery, and could have lengthened the observational arc by several weeks. Once operational, it may also assist with diameter determination. Overall, NEO Surveyor is expected to find roughly 5 times more asteroids than current systems. B. Vera Rubin Observatory. The Vera C. Rubin Observatory, nearly complete and built by the NSF and DOE, will operate the LSST, the largest digital camera ever constructed at 8.4 meters. Over 10 years, LSST will repeatedly image the sky, producing an extensive, high-definition time-lapse view of the universe. While its primary mission is astrophysics, its wide field coverage combined with deep sensitivity will also make it highly productive for NEO discovery, potentially increasing asteroid detections by another factor of 5 and pushing the known population into the tens of millions. Experts consulted for this lessons learned effort offered differing predictions regarding how many additional Torino Scale 1 events will appear once Vera Rubin and NEO Surveyor data become available. Estimates range from monthly occurrences to several per year, but most agree the number will rise. Still, because these facilities will also reduce orbital uncertainties more rapidly, they may be able to rule out hazards more quickly as well. C. ESA technologies. Future ESA systems such as FlyEye and NEOMIR, if fully implemented, could significantly strengthen NEO detection capabilities. NEOMIR is planned to operate from the Sun-Earth L1 point with a wide field of view of 1.7 degrees to 7 degrees, enabling observations close to the Sun. According to ESA, had NEOMIR already been operational, it could have spotted 2024 YR4 roughly a month before its actual discovery, and it likewise would have been capable of detecting the Chelyabinsk impactor days ahead of its arrival. As noted at the 2025 Planetary Defense Conference, combining NEOMIR space-based observations with ground-based astrometry would have yielded a well-defined orbit and provided earlier opportunities for physical characterization. D. Enhancements to existing technology. Current surveys and observatories, including ATLS, PAN, STA, RRFs, and others, are evaluating upgrades that might improve their sensitivity to objects comparable in size to 2024 YR4. For ATLAS, this includes testing whether 3 exposures per field rather than 4 could be sufficient when linked across multiple nights. Additional efforts involve developing improved software to optimize observing strategies and exploring approaches to better coordinate survey operations with LSST and NEO Surveyor. 8. Expanded staffing for the PDCO. The PDCO currently operates with a very small team responsible for monitoring and coordinating Torino-scale events. Although automation may streamline alerts and communication, increasing the number of personnel would strengthen the organization's readiness, especially in anticipation of a tenfold rise in NEO discoveries once NEO Surveyor and LSST become fully operational. Summary. The review concluded that the planetary defense community successfully executed an observation campaign that led to the discovery, verification, follow-up tracking, and eventual downgrading of 2024 YR4's threat classification from Torino 3 to Torino 0 during its initial apparition. This achievement reflects decades of strategic investment in surveys, follow-up facilities, orbital calculation methods, and coordination mechanisms. Throughout the event, the PDCO and IAW fulfilled all responsibilities and notifications as required by existing policies and agreements. International partners effectively handled the detection, characterization, orbital refinement, information sharing, and planning related to 2024 YR4. They also appropriately prioritized early physical characterization and archival data searches recoveries. As the impact probability rose and the asteroid rapidly faded from view, the lessons outlined in this report highlight opportunities to refine the already strong processes for coordinating follow-up observations and communication among stakeholders. Such improvements will help secure earlier windows for physical characterization and orbital refinement during future Torino-scale events. Strengthening these processes will be essential as the planetary defense community prepares for a significant increase in asteroid detections expected from upcoming advanced survey systems.